Hey guys, we're here for our next session. We have the co-founders of UMA and also Balancer. They'll be doing a talk around using UMA and Balancer pools to create perpetual synthetic tokens. And I'll let them take it from here. Can you just confirm in the chat that you can hear them?
Hey guys.
Hey guys.
I hear some echo. Do you as well, Hart?
Works for me. See, no one's saying in the chat they can hear us yet.
They
okay,
can hear
people
us.
Can hear us. Cool. Fernando, kick it off.
I'm hearing some echo. Is that?
So that's just on your computer. You can either ignore it or you can refresh your browser.
Okay. Let me refresh it. Oh, wait.
Guys, Fernando's here from Brazil. We're all over the place. So here, I'll get started just giving quick introductions while Fernando's getting that.
Can you hear me now?
Yep. Go for it.
I solved it. Yeah. Cool. Yeah. So guys, this is Fernando from Balancer. I'm here with my friend Hart from UMA. We're going to talk today about how you can build perpetual synthetic tokens using UMA plus Balancer. So yeah, without further ado, let's hop into the presentation. Good. So the agenda for today is we're going to overview Balancer, like understand what it is, and also UMA, how why perpetual synthetics are hard, and what we came up with combining Balancer and UMA to solve this hard problem. So we're going to go deeper into that solution, and we're going to leave a lot of time for you guys to ask questions. So what is Balancer? So Balancer is an AMM protocol, automated market making protocol, that allows you to provide liquidity on your own terms. What does that mean? It means that anyone can permissionlessly create a liquidity pool with any number of tokens, 2 or more, and each token has a weight, which is the share of value that that token has of the total pool. And Balancer, what Balancer does is it continuously rebalances those tokens in that pool. So whenever one of the tokens goes up, let's say we have a pool of 30% 0x, 30% BAT, and 40% DAI. If 0x goes up, then Balancer lets people buy 0x from that pool, so it sells it, and vice versa, so that whenever let's say 0x goes up, then the pool is selling 0x in order for the percentage of value of 0x in that pool to remain constant at 30%. What is that? That's an index fund. That's an ETF. It's something that in the conventional finance world, you have to pay to invest in. And Balancer flips that upside down. It pays liquidity provider to add liquidity to the Balancer pools, which are like ETFs and index funds. Now, there's 2 types of Balancer pools. When you create a pool, and again, you don't have to create a pool. You can invest or add liquidity to an existing pool. But if you want to create a pool, it will start off as a private pool. That means that you can do whatever you want. You can change parameters. You can add new tokens. You can change weights of tokens. You can change the swap fee. You can do whatever you want. Now, there's a possibility of turning that pool into a shared pool, which is a one-way street. So once you change your pool to a shared pool, other people will be able to provide liquidity to that pool, but then nothing can be changed in that pool. No parameters can be changed. And that is to prevent the creator of the pool from stealing other people's money, because they could just add any random token and dump it into the pool. Now, one nice thing about private pools is that the creator of the private pool doesn't have to be an externally owned address. It can be a smart contract. And that's what we call smart pools. So that smart contract can take liquidity from outside and funnel it down to the pool it controls, but it can also adapt the parameters or any variables of that pool. A simple example of that is a dynamic fee pool. So whenever there's a lot of volatility, that smart contract that controls that private pool can increase the fee. And if the times are more calm and less volatility, then it can reduce the fee. It's pretty much like surge pricing that we see in Uber, and that makes things a lot more efficient. And the solution we're going to show you today is a smart pool. So it's we're going to talk about that. So The idea of Balancer is for it to be a building block for other applications, and you can check it out in more detail on our website. I'm handing it on to the Art to talk about UMA now.
Yeah, thanks, Fernando. And guys, I apologize in advance because Fernando's controlling the slides, so I'm going to be yelling at him to flip slides forward. Fernando, can you hit the next slide? So like Fernando presented Balancer as sort of infrastructure or building block, we really look at UMA as an infrastructure or a building block for what we're calling priceless financial contracts. This is DeFi contracts that are designed from their outset to minimize Oracle usage. And they're designed to minimize Oracle usage because we think that's one of the major failure points for both security and scalability that's plagued decentralized finance. And you can really think of the platform as having two interwoven components. One side is these so-called priceless financial contracts designed to, again, minimize Oracle usage. And the other side is this data verification mechanism, which is a type of shelling point Oracle, a sort of maximally decentralized Oracle that's designed to be used only rarely when there's a dispute that kind of bubbles up from the contracts themselves, a dispute that needs to be resolved by this decentralized network. So the first contracts that we're building with UMA are what we're calling priceless synthetic tokens. And these are ERC20 tokens that can track anything while minimizing the need for on-chain price data. So we can create synthetic tokens that track gold, for example, without needing to push the price of gold onto the chain. Can you hit the next slide, Fernando? So our priceless synthetic token design, we just actually, our code is all available on our GitHub, which we'll point to later. We just had it audited by Open Zeppelin. The draft is back, and we'll have that final report published very shortly. And it's going to be the first contract that we're registering with our DVM that we actually just launched this past week. And these synthetic tokens, I won't go deep into the priceless concept. My co-founder, Allison, did an excellent presentation yesterday as part of this conference. But these are contracts that use this challenge response framework. You can almost think of it like almost like a layer 2 for DeFi, where contracts themselves are assumed to be correctly collateralized until they're proven not to be. You can read more on our doc site. I won't go into too much detail, but the important note is that synthetic tokens that we use have an expiration date. They are not perpetual. Next slide, Fernando. And the reason why those synthetic tokens are not perpetual is because perpetual synthetics are really hard. If you look at traditional finance, there really is no concept of a perpetual future. That doesn't exist. Futures have quarterly expirations typically, and any swap always has a maturity date. And the reason for this is that futures or synthetics or derivatives of any type need to have convertibility to their underlying asset. So you can't just have something that you say is supposed to be worth something else without actually saying, okay, wait, at this date, at this expiry date, you can convert this future for the underlying barrel of oil or bushel of wheat or whatever it's supposed to track. So the thing that's kind of interesting to point out here is that before that expiry date, it's actually quite possible for the synthetic to trade at a different price than its underlying asset. And this in traditional finance, this is called the futures cash basis, the basis being the difference in price between the synthetic and the underlier. And what we have by arbitrage, by pure arbitrage, is that this basis, we know at expiry, this basis will equal 0 because an arbitrageur can buy the cheap thing and sell the rich thing. And at expiry, they can convert the two between each other. So we know that this expiry date is going to bound the price of the synthetic to at least reasonably track the underlying asset. Next slide, Fernando. If we don't have an expiry date, if we just purely say, hey, this thing doesn't expire, we have a big problem because there's now no mechanism to keep the synthetic from targeting or tracking the underlying asset. It just really doesn't work. Next slide. So you guys might be asking, well, wait, we've heard of these perpetual futures or perpetual swaps on something like BitMEX. How does that work? And it's actually, BitMEX was quite clever in how they kind of pioneered this concept, where they created this perpetual experience for futures by having the exchange itself roll positions where futures, where the exchange, instead of forcing traders to sell the expiring future and buy the next one, the next expiry date, the exchange does that automatically for the user and adjusts it with this so-called funding rate. And what I'm really doing here is I'm framing BitMEX's perpetual swaps. One way to think of that perpetual swap is almost like an 8-hour future, a future that expires every 8 hours, that the exchange is auto rolling for you while you pay this funding rate adjustment to keep the synthetic tracking in line with the underlier. Hit the next slide. So what Fernando and I are going to present is a design where we can mimic that perpetual experience, but for synthetic tokens. So we're going to go through how we can use balancer pools to roll forward a series of expiring tokens. So instead of forcing traders to sell or redeem the, say, May expiry token to buy the June one, we're going to use a balancer pool to conduct these rolls in an automated way. And the really cool thing about this design is this method is purely using arbitrage to conduct the roll, and is actually completely trustless. There's no centralized operator or centralized price feed being used for the funding rate adjustment, or being used to figure out when you should buy or sell one future for the or one token for the next. Hit the next slide. Okay, so this is the point of the talk. Balancer plus UMA, we get perpetual synthetics. One more. Here's me drawing more graphics about how this works. So the idea in itself is pretty simple. We're going to have a pool that starts with 100% of what we're going to call the front token. So right now, let's say if we did this for gold, let's say this is the May expiry gold token, and it's going to start with none of the back token, which would be, say, the June expiry gold token. And as the month goes on, we are going to decrease the percentage of the front token we own and increase the percentage of the back token. Next slide. This is me just writing out this mechanism in steps. So let's use this front and back month token concept. The perpetual token is actually the pool that's holding both these front and back tokens. We start the month with 100% front, 0% back allocation. We end the month the other way around. At the end of the month, the back token becomes the new front month token, and we add a new back token to the pool and repeat this process. So voila, we have our perpetual token that's continuously rolling these expiring synthetic tokens. And I'm going to let Fernando take over and tell you how we actually can build this with Balancer.
Yeah, so thanks, Hart. As I told you guys, this is a smart pool. So it's a smart contract that deployed a private balancer pool, so it can do whatever it wants with the pool. But its code shows that the logic, how it will let people poke the contract to update the weights, it's all like on the blockchain, right? It's all open and anyone can verify it. So yeah, so actually we can't have 0 and 100 because of like maths limitations. But in practice, we can start with 98 of the front token and 2% of the back token, and then flip those weights. And actually, I haven't mentioned that, but every balancer pool or every smart pool is actually an ERC20 kind of contract. So you can own a percentage of that smart pool. So if you own a percentage of the contract, the smart pool contract that does this rolling perpetual synthetics, you own actually a perpetual gold token, right? So you don't need to worry about buying the new expiry dates because you own the private, like the balancer pool token that does that automatically for you. So that's pretty cool. Just for you to understand, the smart contract cannot do things on its own, like by itself. So actually what we do is we allow anyone to poke the contract and update the weights of front and back token as time goes by. And they are not going to do that every time. They will wait until the token that they can update is has a delta big sufficient to have a meaningful arbitrage opportunity that it's up to them to define how much marginal profit they want. So that's kind of a race to bottom. And the more bots we have doing this, the more efficient this rolling synthetic pool will be. I'm going to show you a quick demo showing a low-code testnet that I implemented. And you see that we start with June and July, 2 tokens, and now I'm compiling this locally. It's the configurable rights pool that we talked about. It's going to be audited very soon and open to anyone to use. So the idea is that you can build that, but you can also build a liquidity bootstrapping pool where you can sell some of the tokens of your contract or of your project. It has a lot of different utilities. So now we start the pool with 97.5% of 1 month, which is June. So it's just deployed the factory. And it said yes. So from the block 2753, anyone who pokes the contract can start flipping the weight. So every block that passes, there's a new weight that anyone can poke the contract and bring it to that new weight, thereby creating an arbitrage opportunity. Here you see that by the end of the period where the blocks are updated, there's no way anyone can change the weights anymore. So there's no arbitrage opportunity. And here we swapped June for August, and now, sorry, June for August, yeah. And now we have July that had pretty much all the value in the pool, and August that had just a little bit, 2.5%. And again, slowly we let July be replaced by August. So August is the new front month, and July is the back month. So as you can see, it's working. It's still local net, but it's going to be deployed to mainnet soon. So let's get back to, so what are the pros and cons of this approach? So there's no need for an oracle here, right? Anyone can define what they think is the best price and poke the contract whenever they want and do an arbitrage. There's no trusted third party. And here I take a moment to just say that the Balancer smart contracts factory, there's no admin key. There's no way we can kill switch, or there's no kill switch. We cannot kill the whole system. We can't do anything. It's completely trustless and permissionless. So there's really no trust assumptions here. Apart from the token that's added, the new token that's added is added by UMA, because they know what is the address of the new token being generated. But that's still also possible to automate completely. The con is that arbitrageurs are needed. So we need people to swap those 2 tokens to make a profit. And this is like a common assumption that we have in DeFi, right? So lots of things depend on keepers like MakerDAO and Compound to liquidate things. So that's kind of the con we see in this approach. So yeah, we're soon going to be on mainnet. You can check out the smart contracts on our GitHubs as well, and documentation websites. This is all recorded, so you can kind of take a look at that later. And now we're open to questions. Anyone, any question will be very welcome.
Throw your video back up, Fernando.
Yeah. Gonna do that.
Okay. So we got one question here. What are the pros and cons of using perpetuals with front back tokens versus a depth pool model with price settlement and no rolling expiry like synthetics? So that's I mean, the difference here is the synthetics model for how they collateralize their contracts is just quite different. In synthetics, you are collateralized with the SNX collateral. And so you don't have, you're trusting this pool to make good on the promise that this token will be worth what it is. So it's just a very different sort of trust model. Here, the types of synthetic tokens we're putting in this balancer pool are closer to like a DAI design, where they're backed by other collateral that's tied just to that synthetic token itself. So you know the collateral behind that individual token.
Next question, maybe I can take that one. What does the arbitrage bot have to do? So the arbitrage bot has to buy a token that we want to kind of remove from the pool and sell or put back the token that we want to increase the amount of value in the pool. So the token that's close to expiry, we want people to buy those tokens and in return put in the pool a newer token. And that's going to be at some point, since the weights are going down, if no one trades, that means that the front tokens is getting cheaper and cheaper. And at some point, it's going to be an obvious kind of opportunity. Like you buy gold in June for $1,000, and you get gold in July that's worth $1,200. So it's pretty obvious arbitrage opportunity. And the more efficient the bots are, the lower this gap will be, the smaller this gap will be.
We got another quick question related to arbitrage bots. How could a third party set up an arbitrageur? I mean, that's something that we haven't got to yet. We'll be building sort of example arb bots of how people could do this, could interface with the balancer pool. There's one really interesting concept to just touch on here, where what's going on with this balancer pool doing this role is akin to a futures role in traditional financial markets, where you have longs and shorts that are both trying to roll. Both longs and shorts don't intend for their risk to end at the expiry date. They usually want their risk to be perpetual and persisting across a longer period of time. So when in traditional markets, you kind of have this battle where longs are trying to roll, they're trying to sell the front contract and buy the back contract. They're trying to roll forward, and shorts are trying to do the opposite. And the price at which they do that, it kind of depends on how they trade, the trading dynamic between the longs and shorts in that role. So I'm only bringing this up because when you talk about arbitrage bots, there's this really interesting concept here where we have the balancer pool, which we know what it's trying to do. It's trying to roll forward. It's trying to sell the front contract and buy the back contract. But you also have on the other side a whole bunch of people that have created these tokens, the sponsors of these tokens, that are actually trying to do the opposite thing. The people that have minted tokens that have this expiry date, they're trying to actually buy back the front token that's expiring and mint new risk and sell it in the back token. So there's this really interesting market dynamic that, again, we'll have to see how it plays out, where you have the balancer pool rolling forward. You have token sponsors that have minted these tokens going the other way. And we're going to have this arbitrage bot that effectively would look like a token sponsor creating a perpetual debt position that continuously mints new debt as time goes on. So that was maybe a more nuanced answer than your question was, but I think it's a pretty interesting kind of arbitrage bot that we'll end up building.
And if you allow me to add something to that, Hart, I think, so one good thing about Balancer is that we can have more than 2 tokens. So we could have like 5 different months in that same pool. And that would allow not only for the Balancer pool token holder to get exposure, like perpetual exposure to gold in those, in an average of 5 months, but also for people who want to have specific exposure to different months to trade those against other months. So it's a one-stop shop where you can like buy and sell specific months for others, but you can also hold the kind of the pool share, which allows you to have this perpetual exposure. So it's a kind of a solution that creates liquidity for individual expiry dates as well, which is something that is very often a problem with synthetics. Hart, I'm sure you agree with that, yeah?
Yeah, totally. All right, Fernando, what should we answer next?
So let me see. What do you think Balancer UMA and DeFi derivatives trading in general will look like in 5 to 10 years? That's a very philosophical question. I believe that a lot of things will be brought to Ethereum, will be tokenized, if not on Ethereum, on another chain. And the protocols and platforms that are well positioned to kind of get all those tokens and those derivatives is going to see a lot of volume and success, I think.
Yeah, I'll use it as an opportunity to shill Balancer because I think it's pretty cool, Fernando, like what you're building here. I'm really bullish on the whole AMM concept, the whole automated market maker concept, and this idea of being able to have these programmatic pools of liquidity. And again, what Fernando and the Balancer team are building with this configurable rights pool concept. Like what we're talking about here is just one use case of how we are programming this balancer pool to do cool things. There's kind of like the design space is massive. But this idea of having a pool of liquidity that anybody can trade with, and then having programmatic ways of changing the parameters of that pool of liquidity is, to me, really remarkably powerful. And I think that that's going to allow for innovations in finance that actually aren't possible or aren't doable in the traditional financial world. I'd even say like this whole idea of trying to build a perpetual synthetic that doesn't really exist in traditional finance. BitMEX is kind of the closest. BitMEX kind of invented this perpetual swap thing, and it's pretty interesting. And so we are in this design space where I think DeFi and derivatives are going to let us create some pretty cool products.
Thanks, Art. I'm very bullish on UMA too. Yeah.
So there's a couple questions here on mechanics, like what defines expirations, and like why not 3 tokens. And also there's a question here of how do you handle ambiguity in price? Like oil can mean lots of different things. The point I'd want to emphasize, guys, is this is a highly parameterizable thing. So you could, in this design, we're just talking about the concept here. So it doesn't have to be monthly expiries at all, but we just did that as a kind of common concept. It could be quarterly expiries, it could be whatever. The underlying expiring tokens should be designed to track a known index or quantity. So the question about whether, like for oil, is it WTI or Brent, or what oil index are we talking about? That specification should be reflected in the underlying expiring synthetic token that you create with the UMA infrastructure. And then you should design the pool. The pool would be designed to only flip between tokens of the same specifications, of the same underlying index.
All right, guys, I think we can take one more question.
Okay, Fernando, why don't you pick something here?
Sure. So there's a few questions about the weights and how you, if they're always, summation is always 100%, and if we can take 3 tokens. So yeah, as Hart said, this is like a very simple first implementation of a rolling synthetic. It could be 3 tokens, 5 tokens. In the current version of Balancer, we have a limitation of 8 tokens per pool, but you can have trees of pools. So you can have pools that are made up of other pool tokens. So you can have like 64 different tokens in 2 levels of Balancer pools. So yeah, it's the nice thing about both UMA, that where you can create like a synthetic that tracks anything, that like it's pretty cool, very, very open, and Balancer as well. I think we're kind of like positioning ourselves as primitives and building blocks for the space to build on top of. Yeah, so before we go, thank you so much, Shinju, for this. Thanks everyone that's been listening. Thanks, Hart, for your hard work.
Thanks, Fernando. Thanks, Fernando. Thanks, Fernando, for putting together that cool demo. Yeah, guys, we both have lots on our documentation site, and we have a team Slack channel that's open. A link on our documentation site. This stuff is really close to being live on mainnet, so we want to get out there and have people play with it, and we're excited.
All right, guys.
All right. So now, do we offer
your next session?
All right, cool. So we're going to transition to the next session now. Thank you.